Okay, so what we are looking at is lesson 12. And so some things that we have to think about here, we do know that the periodic table contains really good information about the atoms, or more so the elements. And we have learned that elements on the periodic table are only made of atoms of that element. So in the last lesson, we learned that a sample of gold is only made of gold atoms. Okay, it's not a mixture of other things. Okay, so some things that we're going to cover on here. Each successive element contains atoms with one more proton than the previous element. The atomic number of an element is the number of protons in an atom of that element. In neutral atoms, the number of electrons is equal to the number of protons. The number of protons plus the number of neutrons in an atom provides the approximate mass of a single atom. And then the decimal number that we see on the periodic table block that you also saw on those cards from lessons 9 and 10 in the last section represent the average atomic mass of an element's atoms, and that word average is really important there. Okay, so some learning goals that we have here. Learning goals that we have at the end of this lesson, you should be able to do 3 things. You should be able to distinguish between what is an atomic number, what is the mass of an atom, and what is the average atomic mass, okay? Those last 2 are really important to understand because a lot of times people get those confused, and we'll make that really easy to understand, okay? You're also going to be able to extract information from the periodic table related to atomic structure and atomic mass. So you've already learned within the last few lessons that the location of an element on the periodic table can give us some really great information about that element. We've talked about reactivity. We've talked about the columns. Whatever column it's in, that's how many valence electrons we have. You know, if you're in group 1, you have 1 valence electron. If you're in group 2, you have 2 valence electrons. And again, we're going to learn more trends about positions. But we're going to be able to look at those blocks on the periodic table and pull out some really good information. So something you need to make sure you have in front of you as you're doing this is a periodic table. We are going to do some practice in this, so it's going to help you. Okay, so let's review a little bit. We do have these 3 subatomic particles. We have protons, neutrons, and electrons. And if you look at the little image down on the bottom right, that little image will show you that the neutron and the proton are relatively about the same size. And the electron is pretty much smaller than the 2 of them. Okay? A neutron has no charge, a proton has a positive charge, and an electron has a negative charge. Okay? The protons and neutrons are located in the nucleus, and remember, those 2 items give that nucleus its overall positive charge, okay? And those electrons are found in the electron shell orbiting outside of the nucleus, okay? So let's do a little warm-up here. So you want to make sure you have a periodic table in front of you. Models of a helium atom and a beryllium atom are right there to the right on your screen. The nucleus of each contains protons and neutrons, and the electrons orbit around the nucleus, okay? I want you to compare the 2 models that you have there. So you're going to take a look at those pictures, and you're going to come up with 3 similarities and 3 differences. So give yourself a moment, pause this, and write down some things. Okay? So I'm going to talk about the similarities. So some things that I can see that are similar, well, they both have a nucleus, okay, and we see, 2 different colors of spheres inside of the nucleus. They both have electrons outside of the nucleus. And so remember, what we're seeing here, this is that simple atomic model that we learned about in the last lesson, and that is really modeled after one of those great models from the atomic theory. And this looks more like the solar system model as we look at the rings. But then the inside, you'll actually see the definition that distinguishes between the protons and the neutrons, okay? So you'll get those from the proton model itself, okay? So again, they both have a nucleus. They both have protons, neutrons, and electrons. The electrons are on the outside, okay? So some differences. Well, just by what I see here, by looking at these pictures, I'm going to say that beryllium is larger than the helium. Okay, why do I say that? Well, there are more particles in the nucleus. There are more electrons, and then I have more of those circles outside of the nucleus. Okay. You could also say I have more protons inside of the nucleus. I have more electrons. On the outside, I have more neutrons and in beryllium inside of the nucleus as well. Okay, so number 2. Based on the models, why do you think helium is number 2 and beryllium is number 4 on the periodic table? So take a look at them on the periodic table. Pause this. Okay, so the 2 and the 4, those actually correspond to the number of protons and electrons. Okay, so look at the model of helium. Okay, you have 2 electrons on the outside. So everything that we're dealing with right now is considered neutral. Okay, so we have 2 electrons on the outside. Okay, you also have 2 protons on the inside. And we are getting those 2 protons from those light colored spheres in there. Okay, I know it's hard to distinguish, but as you look at more models and you start to understand how can I figure out which is a proton, which is a neutron, it'll make a little more sense, okay? Beryllium, you'll see you have 4 light-colored spheres, so that represents my 4 protons. And right now, we will get to the understanding that currently the number of protons and the number of electrons should stay the same, okay? Let's look at some key terms here. The first one is the atomic number. And this is a set of consecutive whole numbers associated with the elements on the periodic table. The atomic number is equal to the number of protons in the atomic nucleus of the element. So we have to understand that the periodic table itself is actually organized according to the atomic number, okay? And that atomic number is telling us the number of protons or the number of positive charges that an element has, which we find those, again, inside of the nucleus. So when we look at the periodic table, if you look at the top left, we start with hydrogen, which is number 1. You go all the way to the right, all the way across that row, you have helium, which is number 2, okay? You go down to the next row. You have lithium, which is 3, beryllium, which is 4, boron, which is 5, carbon, which is 6, nitrogen, which is 7. Those numbers represent the number of protons that we have in the nucleus of an atom, and it also represents something that's going to identify, which element we have, okay? So by looking at these little generic blocks, excuse me, that we have on this periodic table here, periodic table blocks, these whole numbers on those blocks, and you'll see this on any periodic table, you'll see some whole numbers, those represent the atomic number, okay? The symbol should also be on there, and a lot of times you will see the name of the element, okay? All right. Next 2 terms we're putting on the same slide. You have atomic mass and average atomic mass. The mass of a single atom or isotope of an element, that is going to be the atomic mass. Okay, this is very specific. Atomic mass is very specific for a certain atom. Okay, the average, which what does it mean if we have the average of something? Well, if you look at your class average or your average in any math, chemistry, whatever, that is all of your grades averaged out, okay? So that's typically going to be in some decimal number, okay? We will learn about isotopes later on. It's like 3 lessons from now, 2 lessons from now. We'll start to learn about isotopes, and those deal with different numbers of neutrons. So we will see different atomic masses for different isotopes. But what we see on the block of the periodic table is a decimal number. So what you see on the periodic table is the average atomic mass of that element, okay? It is the average atomic mass of that element, okay? The atomic mass unit, and this is just the unit that's used for expressing the atomic mass, okay? And it's actually 1 AMU is the same as the mass of 1 hydrogen atom, okay? So if we have 4 AMUs, it's the same mass as 4 hydrogen atoms, okay? All right. The atomic number of an element is the same as the number of protons in the nucleus of an atom of that element. Okay. In a neutral atom, the number of protons is the same as the number of electrons. Okay. So we are under the assumption right now that the number of protons and the number of electrons is going to be the same. Okay. So if I say, hey, find carbon on your periodic table. Okay. So you look at your periodic table and you say, okay, I found it. And I say, okay, what's the atomic number of carbon? You would say 6. Okay, great. We know the atomic number tells us the number of protons. Okay, that's good. We've learned that so far. But then I say to you, what else do we know that that atomic number represents when we have a neutral atom? Well, you would say, it tells us the number of electrons that we have. Okay, in a neutral atom, that means our positive charges and our negative charges balance each other out. Okay, that's how we get that overall charge of 0 that we learned about in the last lesson. Okay, if you look at your periodic table, each successive element has 1 more proton than the element before it. As we go from left to right on the periodic table, you will see the atomic number increase by 1. I like to tell my students, moving along the periodic table is like playing a board game. I know a lot of families don't play board games anymore, but it is very much like playing a board game. You move 1 space at a time, and that atomic number goes up every time. Okay, the atomic number is very, very important. The number of protons is very important because the number of protons identifies what element we actually have. Okay, no 2 elements on the periodic table will have the same number of protons. Okay, the atomic number, even though we are talking about neutral atoms and we like to say the number of protons and the number of electrons balance each other out, the atomic number does not tell us anything about the number of neutrons. Okay, we have to do a little more work to figure out the number of neutrons. And so we can do a little work and say, okay, well, the number of protons and electrons are pretty much the same, and the number of neutrons will be close to protons and electrons when we have a smaller element. Excuse me. Protons and neutrons account for most of the mass of the atom. Well, let's think about it. We learned in the last lesson that protons and neutrons are the most massive particles. They're roughly about the same size, okay? They're way more massive than an electron. And the protons and neutrons are found inside of the nucleus. So remember, when you studied the atomic theory and you were looking at those different models, we learned that the nucleus that they identified is dense and positively charged, okay? So if it's dense and positively charged, that means those protons and neutrons are all jammed in there together, and that's where we're going to find most of our mass, okay? The atomic mass, and again, I cannot stress this anymore, not the average atomic mass, okay? The atomic mass is equal to the number of protons and the number of neutrons added together. Okay, if you know the number of protons and the number of neutrons of an atom, we know the atomic mass. Okay, Where do we find the average atomic mass? The periodic table. Okay, you can estimate the number of neutrons in an atom by subtracting the number of protons from the average atomic mass of the element. Okay, if we know nothing else, and we know the atomic number and the average atomic mass, both of those we get directly from the blocks on the periodic table. We will take that decimal number from the periodic table. We will round it to the nearest whole number. Remember the rules of 0.5 and up, round up, anything lower than that rounds down. So you will do some subtraction there. Okay. Excuse me. To the nearest whole number. Okay, so let's do an example here. Let's say I am working with aluminum. Find aluminum on your periodic table. Okay, aluminum has the atomic number of 13. Okay, its average atomic mass, which we get right off that periodic table, is 26.98. That rounds up to 27. Okay, so if I want to figure out the number of neutrons just with knowing the number of protons and the average atomic mass, I want to round that average atomic mass up, and that's going to give me my estimated atomic mass. Okay, so I'll do 27 minus 13. 27 minus 13 gives me 14. So I will generically say that aluminum has 14 neutrons. Okay, that's just for that example. Okay, another example here, let's look at neon. Neon has the atomic number of 10. Atomic number tells me I have 10 protons. Okay, the average atomic mass I take right from the periodic table. That is 20.1797. If you look at your periodic table in the textbook, it's 20.18. A great thing to do is just to round to 2, or look, if you have a periodic table that has more than 2 decimal places, just go to that 2 decimal places. It doesn't really make that big of a difference when you're, doing average atomic mass and rounding to the atomic mass, okay? So to figure out the number of neutrons, I do 20 minus 10, okay, which gives me 10. Okay, the atomic mass of an atom is determined by summing the number of protons and neutrons. It is not identical to the average atomic mass given on the periodic table. Again, I'm going to stress this 1,000 times over. Atomic mass and average atomic mass are not the same thing. Okay, you are not going to have a fraction of a proton. You are not going to have a fraction of an electron. You are not going to have a fraction of a neutron. Okay, your atomic mass is whole number plus whole number. Okay, your average atomic mass is an average. We get it right from the periodic table, and that comes from looking at the masses of all of the isotopes of that element. Okay, if you change the number of protons in an atom, you also change the elemental identity of that atom. Someone in the lesson 11 follow-up question said that you can take away the number of protons, and that's going to give us a new element, and all you have to do is take away protons and add electrons. No, that doesn't really do it. That gives us an ion if we give up or gain electrons. And if we do anything with protons, if that number of protons change or our atomic number changes, that means we are going through some form of a nuclear reaction. Alpha decay, beta decay, gamma, any of those would cause a change in the number of protons. We cannot naturally do that. Okay? So please don't think, okay, I can just add 2 elements together like you would do 2 fractions or something, and get a new element. No, we have to go through some type of nuclear reaction to get that. Okay? Okay, so let's do some practice here. Okay, so let's do some practice here. Sorry, I had to take a drink. Let's do some practice here. Let's look at these blocks of the periodic table. The names really aren't that essential, but what we can see here, we have a symbol, we have a whole number, we have a decimal number in each of those blocks, okay? So what we have to notice is that for F, let's identify the atomic number. Well, remember, the atomic number is the whole number, so that means I have 9, okay? The mass, we don't know that just yet, okay? This number right here is the average, okay? This number here is the average, okay? That's not just our mass. So let's look at some other things here. Well, the atomic number can tell us what 2 things, because we are dealing with neutral atoms, okay? This atomic number can tell us the number of protons, so there we go. It can also tell us the number of electrons, okay? If we want to figure out the number of neutrons and all we have is the average atomic mass, we have to round this to the nearest whole number. Well, this is pretty simple because it's kind of already done for us, okay? When we round it to the nearest whole number, that gives us our mass. So that's going to be 19, okay? The number of neutrons is the atomic number minus your mass number, okay? Or sorry, I have this switched. Mass number minus atomic number. Okay, mass minus atomic. So we have 19 minus 9, which gives us 10 neutrons, okay? Let's do this practice over here. Take this off here. Okay, so this is thorium. TH is thorium. Let's look. Our atomic number, remember, that's the whole number that's already on that block for us. We know the atomic number is also going to tell us the number of protons as well as the number of electrons, since we have a neutral atom, okay? The mass, we don't know just offhand, because remember, this is the average. But to figure out the mass of just this atom, let's do what's the rounded number here. This would be 232. Oops, 232. Okay, so how do I figure out my number of neutrons? Well, we want to use that same mathematical formula, 232 minus 90. That's going to give me 142. Okay, 142. And we'll do some more practice, and our goal for Friday is to do some more practice together. Okay? Okay, so use your periodic table to identify these elements. So take a look at your periodic table. What element has an atomic number of 18? What element has an atomic number of 18? So remember, atomic number, that is the whole number on the periodic table. Whole number on the periodic table. Excuse me. What is it? It's argon. Okay, its symbol is Ar. What element has 3 electrons when atoms are neutral? So this is the big word here. We're talking about things that are neutral. So if it's neutral, that means the number of the protons is equal to the number of electrons. Okay? So if my number of electrons is equal to my number of protons, if I have 3 electrons, that means I have 3 protons. Number of protons identifies the element. So what element has the atomic number of 3? Lithium. Okay? What element has the atomic mass of 16.0? Okay? Atomic mass, that means this was rounded to get here. This was rounded to get here. So you want to look on your periodic table. I would suggest starting in hydrogen and going all the way until you get something that's close to 16, because you're probably not that familiar with something that has a mass of 16, but as you use the periodic table more and more and more, it will make a lot more sense to you. Well, since this is a rounded number, it could be anything close to that, but thankfully for us, oxygen has an average of 16.00, which when we round this, it gives us the same number. Okay? Something to understand, we are going to practice identifying protons, neutrons, electrons on Friday. You're going to have a document that you're going to be able to fill in, and so you're going to fill that in along with me. You want to make sure that you are practicing that. So something that's really important is to go back over your notes before class on Friday. And since we are doing a Google Meet, the big thing is have your periodic table handy.